Hey everybody, Seven Ravens Permaculture here with All Points Land Design and Permaculture BC, and this guy. This is Brandon Bauer.
Hello.
He's probably one of my favorite people in the world. Probably. He's been a permaculture educator and designer for
10 years.
10 years, and you did some work with the Bullock brothers.
Yes, sir.
You were an intern there.
From 95, 96 to 2001.
Right, so worked with the Bullock brothers homestead over on Orcas Island. If folks don't know about that, check it out. And then after that, you came up to,
Salt Spring.
and what'd you do here?
I had a farm and did a CSA program and growing a lot of food and teaching and outreach, community work. Started the food bank garden here on island.
No big deal.
And we did stuff for Seeds of Change and contracting and installations and etc.
This guy, right? Which brings me to a point which we'll just quickly go upon and then we'll move away from, is lots of people out there doing incredible stuff in permaculture that we don't know about. And so it takes people like us who put cameras in the faces of people like this to let other people know about them. But we'll move on from that.
Teehee.
Brandon and I have been designing and working together for the last couple of years, and it's as you can see, we have matching uniforms. These are Filson vests. We have to make sure the uniform looks appropriately correct. Anyways, today we're going to be talking to you about something pretty exceptional. It's not just a plywood box. This is a charcoal making
Rocket stove.
water heating rocket stove. So it was created by
Hideki Morino
Hideki Morino.
from Japan.
And what we have is Brandon and I are going to run you through the entire system. So let's start at the bottom where we start to put in fuel stock, and then we'll move up. What do you think, Brand?
Yeah, that sounds good.
Okay, so we're going to come all the way over here to the far side of the box. And what we can see down here is we have a inlet, and this is actually an air inlet. And as Brandon was telling me, is that Hideki had a small milliamp computer fan that he put into the bottom of a 1 liter milk jug, and then he had a pipe. And the end of that pipe gets fed over here, and so it pressurizes the system. So that's the only input here in terms of pressurization or electricity. Now, that then goes through this small insertion box or opening, and then it goes into 1/3 of a 55-gallon drum. And that 55-gallon drum has a lot of wood that is placed into it. And above it is the next 2/3, so from about here up, is the next 2/3 of the drum. So you can imagine that the bottom is there, then it comes up, and then we have this drum, this the next 2/3. Now there's holes drilled in the bottom of that drum. And in the center, connected to the firebox at the bottom, is this steel pipe that we see up here in the middle. So inside this drum has been filled with a bunch of wood, and below in the firebox has been a lot of wood placed in. So what happens is we light the firebox, and that produces a fire and heat. And this in turn starts to
heat up, and the wood that we've placed inside of the 55-gallon drum lid here begins to smoke as the heat increases inside the firebox. So as the heat increases, the wood begins to smoke, and the smoke is in an oxygen-free environment because it's inside this lid and buried under the earth. So as it heats up within the charcoal making chamber, the smoke is pushed out of the charcoal and needs a place to go. So then as it's expanding under heat, it needs a place to go. So we've drilled holes in the bottom of the charcoal making chamber, and the smoke gets pushed down by expansion, actually gets pushed down into the combustion chamber and then ignites. And when it ignites, it takes the temperature from roughly 150 degrees Celsius to anywhere between 300 and 500 degrees Celsius, running strictly off of the unused or wasted combustibles that we know as smoke. And in the end, after a 4 to 6 hour process, instead of the normal 2 to 3 day process, under this system, we're able to make extremely high quality charcoal with very, very little pollution, and using very, very little fuel to do it. As Javin said, only a small electric fan, and we did nothing but feed this with small 2x4 scraps all day. And we were able to maintain an average temperature of about 320 to 340 degrees Celsius throughout a 4-hour combustion period.
So let's talk a little bit about feedback loop. So we're making this process. We've put time and energy into this apparatus. We've deemed it to be an appropriate technology. Now we've got a really interesting piece over here. So over here on the lid, we've got a small steel pipe, and we're using that as feedback. Now Brandon was just explaining this to me. It's actually based on the color of the smoke, and that tells us a few different things. Could you explain that?
Yeah. Well, as the wood heats up in here, and the smoke gets pushed out of the wood, the impurities, if you will, mostly hydrogen and nitrogen, but a whole lot of other elements, as it gets pushed out, when we start, and just imagine like lighting a fire in your wood stove or any other fire, even a campfire, the initial light, the initial burn is dirty. And so you get a lot of like smoke, and sometimes it's yellow, sometimes it's white, and sometimes it's like a bluish color. And brown or gray is really dirty. So like your neighbor's burning leaves, that's not so good. And then as the process goes, and as the charcoal cures or cooks within the combustion chamber, the smoke, the color of the smoke gets cleaner and cleaner and cleaner. So it goes from like white yellow to bright white to like a pale white, creamy, like a pale white see-through, and then eventually to almost a blue or a purple before disappearing entirely. Now, once we get to a point where it's at that light white, kind of opaque and moving towards blue, you can actually light the smoke on fire just straight out of this tap. It's not good because we want to keep the smoke in there because we actually want the smoke to get pushed down into the combustion chamber to make more heat, to make this a more efficient process. But, you know, for the fun of it, and for the feedback loop, direct visual reflection of how the process is going, we can light this on fire and just see what's happening. We also built a little grill over this the day that we did it, and we made miso soup, chai tea, and made some beans and rice as well. So we made dinner, we had lunch, we had tea, and we had soup all over this while we were making hot water, and while we were making charcoal.
So the functionality of this for a home scale, a homesteading situation is immense.
It's huge. And the implications for people worldwide that are dependent upon charcoal as their cooking fuel is huge, because charcoal making is one of the largest forms of pollution in non-industrial areas. Because it's 2 to 3 days of smoke coming out into your living environment. So by using this technology to apply to an old technology, we can really clean up the process of making charcoal, which has a rather high impact at this point.
Now, there's one more thing that they added to this entire system that I wanted to give folks a quick sense of, and that's over here. We've run just a regular garden hose, and then there's a fitting, and then there's a copper pipe that basically runs around the entire outside of the charcoal box, and then comes out here in an outlet with a little valve. And how did the story go, Brandon, when you guys turned that on?
Well, one could say that it would have been wise to remember that 390 degrees Celsius is really hot. But it went really smoothly for what it was. Michael said, I have this copper coil, and I've had it for about 25 years, and it's a really odd diameter. It's 5/8 of an inch diameter. So he couldn't find any fittings for it. So I pulled out the calipers and started working at it and looking at it, and realized that 5/8 of an inch diameter copper pipe is 3/4 of an inch outside diameter. So I literally slid a piece of 3/4 inch pipe over top of the 5/8 inch pipe and soldered it into place and moved up to standard fittings. So when we lit this up, it was at the end of the process because we didn't want any of the heat to be stolen from the combustion chamber until we were done, which meant that all the earth and all of the metal and all of the air inside of that pipe was extremely hot when we pumped it full of cold water. Well, what we got was a roughly 40 to 50 foot column of steam that encased half of that house over yonder. It did no damage. It lasted for about 30 seconds in solid pressurized steam before it condensed, and the water that came out was still boiling when we put it into a metal container. So it is a really effective way to make a large volume of heat very quickly. The reason that we didn't use it during the charcoal making because we needed the heat to keep the combustion up. But then the reason that we used it at the end was because it allowed us a really fast way to cool the system down so that we could then also get to the charcoal to see what we had made.
So taking the heat from that situation and putting it into practice, not only for another use, but also to cool down the system so we can access it.
Yes.
Right.
So it's multifunctional. Heat exchangers are also taking heat away while we're then making heat to put over here.
For an intended objective or purpose. Within the context of what we're doing.
That's right.
Brilliant. Now, at the same time that this workshop was being run, we were also doing a pruning, coppicing, woodlot workshop to really talk about how do you get uniform feedstock? How do you develop a coppice woodlot? So this is really, when we take a look as a technology, this is a cradle-to-cradle technology. We can utilize absolutely everything we have here in the maximum form. Now, some of the cool things about charcoal, as we take a look at some of the writings of Albert Bates and the biochar solution, is that we've got a high porosity, a high surface area material.
300 meters per gram.
No big deal. It's small. But what's interesting about that is that this is now recalcitrant carbon. This is crystalline carbon, and so it's quite structurally stable in the soils. So some of the uses we can have for this is we can take compost tea, or we can take fungi and we can inoculate this, and we can place it back into the garden, back into the woodlot, back into the fruit trees, which increases the total availability of biological life to these plant systems. We can also use it to capture and absorb moisture in the air, which is something that here on the West Coast is a beautiful thing. I recently visited the local abode, and there was a bunch of charcoal in there, and it was a very, very dry outhouse. It's probably the driest place on this farm right now. And again, we're at Seven Ravens Permaculture Academy and an eco forest. And then we can eat this as well. So in Japan and other places, water filtration. So the uses of this are many. Anything else you'd want to say to folks that were thinking about maybe doing something like this, Brandon?
Yeah, do it. Yeah, build it. Don't just talk about it. Don't just think about it. Get out there and build one, and then play with it. Because the only way that you're ever going to be able to learn anything, especially with this process, you can only do so much by reading books. This is one of those things that we need to do and do more of, because charcoal has huge potential. It's first off, it's one of the most used cooking fuels on the planet, and its production is questionable. It's not efficient. But beyond that, its implications as a fuel and heat source for many people are pretty great. Never mind cleaning water, cleaning the air, dealing with odors, eliminating odors, dealing with water vapor in the house, killing molds and funguses in your living situation. But also eating it, and it helps with your flora and fauna and pulls toxins out of your own system. And there's evidence that says that charcoal-based wood gasification is probably one of our most efficient technologies that we're moving towards. So do some research, find out what that is, and we'll see you again next time.
Thanks so much. This is Brandon Bauer with IntelliKey Nurseries and Design. Stunning. Look how handsome that vest is. Oh, look at this one. I got the same one. Thanks so much, everybody. This is Javan Vernakovich with All Points Land Design and Permaculture BC. Be fruitful and
multiply.
Thanks so much, everybody.